Hello friends, I'm Shubham NITW. I'm doing my MTech from NIT Warangal in Mechanical Engineering branch, and today I'll be taking a small session with you and for how to why GATE is important and how to prepare for GATE and what some subject I'll be teaching you and how that subject is related to your life, real life, and how the subject is important to you in GATE also. And after that, a small session I will be taking for you. So, firstly, why gate? Gate will be for you like a junction. You pass that junction, there will be many routes for you to go. Like first will be PSUs. If you will holding a good rank, top ranking, you will be going to the PSU. If you want to pursue a higher career, like higher studies, you need to go through the GATE examination in India for IITs, NITs. They will be taking you after qualifying your GATE examination. And now the state government has also started taking from the GATE examination. So this will be a very great opportunity for you to get for after GATE. And today I'll be taking you a manufacturing science session. So why manufacturing science? Like if you take any example, everything, this board, this pen, this shirt, this eyeglass, everything is going through some of the manufacturing process. So this, you can say, the soul of the world is manufacturing process. Everything is going to be manufactured by some of the means. And why the mechanical? So mechanical manufacturing process, if you going in GATE, how it is important? It is having the 10% weightage in the GATE examination. So it is a great subject for you as well as great things to do. So this is how why the manufacturing is important in your real life. So let's see what I'm going to teach you today. I'll be taking a pouring time calculation video for you. So let's start this. So I'll make this is my pouring basin. Very actually it will not be looking like this in actual, but for calculation, for theoretical, I'll be taking this. And this is my screw. This is my pouring basin, and this is my mold cavity what I'm going to fill. This is point 1, this is point 2, this is point 3. Point 1 and point 3 are exposed to the atmosphere. And this is the height H1 I'll be taking. And this is height H2 I'll be taking. And this overall height is HM. Okay. And what some thing I require: pressure P1, velocity V1, and area A1. Here pressure P2, velocity V2, area A2. Here pressure P3, but here you can see here area, the area of point A1, point 2 and point 3 are same. So velocity and area will be same for this from the continuity equation. A2 V2 is equals to A3 V3. As area is same, so velocity is also same. Okay, so this is how. So firstly, we'll apply the Bernoulli's theorem between point 1 and point 3. Bernoulli's equation between point 1 and point 3. So P1 upon rho g, V1 square upon 2g plus Z1 equals to P2 upon rho g, V2 is V3 square upon 2g plus Z3. P1 is exposed to the atmosphere and P3 is also exposed to the atmosphere. So we'll neglect that. Z3 is reference point for me. So this will be my, like here, from here I'll start calculating. So this is 0 for me. Okay. You can do Z1 minus Z3, that will also come HM only. Now V1. V1 actually here you hold the metal what you have poured here will be in the rest position. So almost the velocity will be equal to 0 for the top layer. So this I will neglect. Now Z1. Z1 is what? Z1 is H1 plus H2 is equal to HM. This is HM. Now V3 is equals, so from here I will get V3, that is under root 2G HM. I'll make this as my first equation. Okay. Now next, I'll apply my Bernoulli's equation into point 3, between point 2 and 3, same Bernoulli's equation. So that will come P2 by rho G V2 square upon 2G plus Z2 equals to P3 by rho G plus V3 square upon 2G Z3. I don't know what will be the exact shape of this screw, but I have taken randomly, like the area at 2 and 3 is equals to like parallel section I have taken. So if this is right, if my assumption is right, like parallel area, so the pressure here, pressure at P2 should be greater than the atmospheric pressure, because if you need to flow, the pressure here should be greater than the pressure here. Here is the atmospheric pressure. So the point 2 pressure should be greater than the atmospheric pressure. So I'm just calculating how much pressure is there at P2. So V2 and V3 is equal to same. So I'll cancel this. Z3 is my reference point. I'll neglect this. Now comes what Z2 is H2. So plus H2 P2 upon rho G is equals to P3 is atmospheric pressure. This is also gone. So this side 0. Now I'll calculate P2 by rho G is equals to minus H2. That will comes to P2 is equals to minus rho G H2. This minus sign is indicating the vacuum pressure. Means if your screw is parallel, then here is a vacuum. Inside this vacuum is creating. So if vacuum is there, all the air what is outside, this will try to go inside. If this air will go, there will be aspiration effect we call. So some blowholes will be formed after the filling. There will be air bubbles. So that we call the defect in casting is blowhole. So to remove this, we'll not take some constant area. We'll take some random area, like I don't know what will be the shape. I'll try like some taper. Sorry, I'll take some taper section here. Now I'll take A2 is not equal to A3. So what will be the case? I'll see. So what we need to find is the volume of mold. We need to find a volume mold. That is, sorry, we need to find the pouring time. How we calculate volume of the mold is equals to area of the mold. Area of the mold is I'll be taking A, and height of the mold I will be taking H. Now this volume should be equal to the volume is coming from this point. So from here the area is A3, velocity is V3. So this is meter square, this is meter, this is meter square, this is meter per second. So some time will be there. That time is your pouring time or filling time. Second. This is for just reference purpose. So we need to find this TF. That is A into H is equals to A3 into V3. But we don't know this A3. So we'll again apply the Bernoulli's theorem here. So between point 2 and point 3. Now what is the assumption? A2 is not equal to A3. So I'll apply P2. But what I know, this point also be greater than the atmospheric pressure. So now I am considering the atmospheric pressure. Atmospheric pressure that should be greater than that. I'm considering atmospheric condition there. Okay. Now P2 upon rho G is equals to P2 square upon 2G plus Z2. Here now comes P3 by rho g, V3 square upon 2g plus Z3. This P2 and P3 I have taken atmospheric pressure. So this will be 0. Z3 is my reference point. Now what is remaining is V2 square upon 2g plus Z2 is equals to V3 square upon 2g. Okay. So from continuity equation we know A2 V2 is equals to A3 V3. I need to convert this V2. Okay, so V2 is A3 by A2 into V3. I'll take this as a area ratio. Area ratio R is equals to A3 upon A2. So what will I get? I'll get from here V2 is equals to R into V3. I'll put it here R square V3 square upon 2g Z2 V3 square upon 2g. Now if I calculate all this, what is Z2 here? Z2 is equals to H2. So here H2 will be here only. V3 square upon 2g I will take common. So here it is 1 minus here if it will go, it is R square. Okay. So this is up to here. This. Now we will go again. Okay. So from here 2GH2 is equals to V3 square 1 minus R square. This is the V3 I will take here 2GH2 and V3 we already found 2GHN. Here 1 minus R square. 2G can say H2HN is equals to 1 minus R square. This R square will take, this will become coming this side, 1 minus H2 by HN. So R square HM minus H2 upon HN. HM minus H2 is H1. So R, this is coming under root H1 upon HN. This R is what? A3 upon A2. So here I can calculate what is the area. If I can calculate area, I can find the calculation, and that TF is equals to A into H upon A3 into V3. So this is my topic. Bye bye.